So,
You started on it?
okay, wait. What does that say on the board? Abe,
Trig 245.
What?
Trig 245.
Trig something. Come on! Look at the extensive notes I gave you at the top.
Extensive notes.
That's actually all you need.
Yeah, that's all you need.
What did you wrong?
245.
I got the answer with -1
See, look at this, multivariable calculus. You know what you have to know in this lesson? The work done is equal to the change in kinetic energy.
Ooh.
Whatever that means.
Think about it.
Okay, number 2. That looks suspiciously like the integral we did yesterday as the example. That looks very suspicious.
I did.
I think it is.
And
Oh,
this,
number 5, okay.
you know this integral that I'm doing right now? This is the same thing as the one we did yesterday, except that was a 2 and a 4. Explain yourself to me.
Wait, did you just memorize it?
What? Yeah, you need to memorize that.
Oh, that's why I didn't understand. I was like, where are you getting these from?
So that so that it comes out with an identity. Well, you don't have to memorize. You can just think, okay, what do I need to plug in there so that I can use a trig identity? It does make sense.
It kind of makes sense.
Okay, so this one, you would let x equal 3 tangent theta. Okay, now, why are you doing that? Because if you plug it in there, you factor out the 9, you'd be left with 1 plus tangent squared theta, which is secant squared theta. And then it can come out of the radical. That's why we make these substitutions, because of the Pythagorean identities. And then dx is equal to 3 secant squared theta d theta. So this integral becomes, on the denominator, the square root of 9 plus 9 tangent squared theta, and dx is 3 secant squared theta d theta. And what are my new limits of integration? Choi! Just read it off your paper. Lower limit. Is 0. Oh, that sounded like a different voice. And the top limit is good. I like hearing quickly. Well, what do we see there? It's pi over 4. I tried to fool you.
I don't think you even noticed.
No. Look, how do you figure out the new limits? Look, this is x equals 0 to x equals 3. You plug in for x there. What happens when I plug in 0 for x? You get tangent theta equals 0. That's why it's 0. If you plug in 3 there, you get tangent theta equal 1. That's why it's pi over 4.
I converted it back to x and then these 3 and 0.
I told you guys don't, so you pull the Ishihara then.
Why?
You change it back to the original variables. Why not change the limits as you go? Because there are harder problems, so sometimes you gotta make like 4 substitutions, and then what? You're gonna go all the way back.
Yeah.
Whatever. Anyway, this is factor out the 9. 1 plus Ishihara, this is for you. Hey, you somebody! That's 9 secant squared theta. So when you square root it, what are you gonna get? 3 secant, well, absolute value of secant theta. However, on this interval, it's positive, so no need absolute value. See, that's why we give restrictions and we put limits on, so you don't have to worry about that. Because if you have the absolute value there with no restrictions or anything, you gotta make piecewise function. And we don't want that, do we? This 3 cancels that 3, this secant cancels one of those, so all you're left with is secant theta d theta, and hey, that's on the list, Abe.
ln absolute value seeking theta plus tangent theta.
From 0 to pi over 4, plug in the top number. Root 2 plus 1 minus natural log 1 plus 0. but natural log 1 is 0, so natural log root 2 plus 1, distributing the natural log, don't
Yes.
dare.
Factor out the root.
That's the answer. Wasn't this like the same answer we had yesterday,
Yeah.
except, oh,
Factor out only the root.
okay, number 4. Number 4, okay, there, this one looks different at least. So this is, by the time we get to the test next week Tuesday, that'll be a little too easy for a test, yeah.
No.
We want an integral that challenges us, because we're BC. 1 to root 2, 8dx all over x squared root 4 minus x squared. So this one, x equals, Tran, what is my substitution?
X squared
Mhm.
x.
Trying to sound on the
That's
TV,
exact-
trying. Trying to look at the TV.
Look at the TV.
It's right there.
It is a TV. No, look over here. Even if you didn't do your homework, at least like piece it together. Like, oh, I saw what we did on number 2. I'm gonna do like the same thing except different on this one. So x equals 2 something theta, 1 out of 3 chance. Unless you don't know anything, then 1 out of 6 chance.
It looks like one of the.
Stop looking at who.
Natural log.
Stop looking at something.
Natural.
Tangent.
No.
Pretty close.
We just did tangent. That's the one with the plus, because the plus looks like a T for tangent. I just made that up now.
You said that's the same as the last problem.
Except.
dx equal 2 cosine theta d theta. Don't forget to put the d theta there, because otherwise it's not equal. So this becomes 8. What do I substitute for dx? 2 cosine theta d theta. Tran, you're going to have another term. X squared will be this squared, so that's 4 sine squared theta. And root 4 minus, if you square that, you get 4 sine squared theta. Now do you see what, wait, Tran, what are the new limits of integration? Read it off the paper.
Power. The top is power 4.
Who does the top first? Nobody does the top first.
I do. Power 6.
Okay.
Power 4.
Okay, good. Finally we got something. Yoshida?
Oh no, I just.
Okay. And then why do we make this up? Why do we use sine? Because right here, if you factor out the 4, you will get 1 minus sine squared theta. Hey, it's about it. 4 cosine squared theta. And then when you radicalize it, you get 2 cosine, well, absolute value of cosine. However, on this integral, cosine is positive, so we don't need it. Everybody understand why these things work now? But ultimately, you're just going to memorize them anyway, right? Okay, let the canceling begin. So all you have left is throw the 2 on the outside. I can't wait to call on the next person. 1 over sine squared theta d theta. What is this integral? Angelo,
-2 cosine.
that's not Angelo's voice.
Yeah, it is negative cosine.
No, okay,
2
very.
and 2 cosine.
What? No, you got it right.
Oh.
-2 cotangent theta. Now, some of you who didn't do your homework are going, "Whoa?" That's because isn't this the same thing as cosecant squared theta,
No.
which is on the list? And then from pi over 6 to pi over 4. Do I need to finish it? No, you guys can plug in the top. I don't trust you. Factor out the constant, and so cotangent pi over 4 is 1. Cotangent of pi over 6 is root 3. And if you want to distribute the tides to -2, you can.
Oh my god, I did it.
And then finally, number 5. We can actually finish early today. That would be a good surprise. Integral 1 to not quite. dx over x squared root x squared. Oh, this one has potential. This has potential. Oh! I don't see it up there because you know what? I'm saving it for the test.
Oh no.
Ha ha!
Ah.
Can you not?
Okay, so what substitution I'm gonna use in this one? X equals 1. We already did this one already. Lau, x equals 1. plus
Tan theta.
tangent theta. Dx is, see plus, tran? The plus sign is like a T for tangent or tran, yeah? Secant squared theta d theta. So dx is secant squared theta d theta. X squared is tangent squared. I can't wait to see what this comes out to. This is like opening a Christmas present. You know, you're gonna do all these substitutions and then the present appears under the tree. Or something. I just made that up. Hey, you somebody! That's secant squared, and when you square root it, you get absolute value of secant, but I'm pretty sure we don't need the absolute value because the new limits are hooey! 1, 2, why are we doing the top one first? Look, what the, this is just like AB. Every integral I've written on the board is from A to B. Why do you guys do it B to A?
Because I'm reading it off the paper.
Oh! Bamboozled.
That's the second meanest thing in it.
What's the first? I do.
Okay, wait, now, how do we simplify this? I guess we've got to change everything to sines and cosines, right? Secant is 1 over cosine, and tangent is sine squared over cosine squared. So if we multiply by the reciprocal, we're gonna get whoop, whoop, cosine over sine squared. Okay, now there's 2 ways we can do this integral. Which way did you do, Hirano?
I did.
No, dude, this is your chance to surprise me.
Lift and separate.
Oh, tangent. Yeah, like, oh no, it changes to cosine.
Use
did.
substitution.
Okay, there's the 2 methods right there. You
One
can do
minus-
u substitution, you could go u
one
equals
minus-
sine theta, or you can do the
Or
good
plug-
way, which is what Hirano said, change this to
Let's do it.
cosecant theta, cotangent theta. Everybody see that?
Yeah.
But if you let u equal sine theta, that would work just as well too. But this one's better because, hey, you on the
So-
list. Who we won on the list? Oh,
Oh.
pretending not to hear me. I know that trick.
Co-
That's a good one.
Negative cosecant.
Very good. So negative
Okay, wait.
cosecant theta from pi over 4 to pi over 3. Factor out the constants. So what do we got? I'm trying to think here. 2 over root 3 minus root 2. I will leave the simplifying to you.
I bet you don't trust.
That's why I did the numbers. Why are you taking pictures? There's only one reason you would take a picture, Lamachane.
Can't see it, so I have to.
That's pretty good.
Oh gosh, you guys are killing me.
Mr. Park, where are you going to lunch today?
I brought home lunch.
Ah.
Turkey sandwich.
Did you make it?
Of course. Well, why wouldn't I make it?
Like,
I thought your wife
like-
was
Wake up my wife, honey, can you make me a turkey sandwich? By the way, give me an apple and cut off the skin too.
Yeah. Do you
No!
What kind of
Cut off the
condiments do
skin
you
of
put
the
on your turkey?
Mayonnaise.
Just mayo and
Yeah.
turkey?
Yeah.
And bread?
No,
No, mustard. Bad.
No mustard. No
What
mustard.
kind of bread?
Wheat bread, loves.
Like the one with
Expiration
the
date
nuts on it?
December.
Oh,
Yeah, Chandler, remember that?
Oh, is this from the
Expiration
Sam's
date December 10th, I think.
Like Sam's Club one?
The one that's on sale.
Hey, once it expires, make it.
Like today, if you go to Subway, it's tuna.
Can you do that?
And that's why I don't go to Subway on Friday.
So, Mr. Park,
Thursday
Subway. You get your bread from the
What's
grocery
Thursday
store?
Or Costco.
Do you get it in the
Okay, one more question, that's it. This is the last question.
This is my last question.
What's your favorite
You know when
bread?
you get wheat bread, do you get the one specifically with like the
Jake knows what
crunchy
that
nuts in it?
What?
No, just regular whole wheat bread.
What do you want?
Okay, no more questions.
No, it does. It has the one on the side. I know what you're
Yeah,
talking about.
it's my
Those are the good ones.
Yeah. So that's Roman meal.
Yeah, that's Roman meal.
It's kind of small. It's not big, but you know, like that size.
What?
No.
You know what bread I
Size
like?
is just relative.
Ezekiel.
Yeah.
No, like there's the Sam's Club wheat bread.
Sprouted bread.
No,
The height of the tree doesn't matter. All that matters is the
Ezekiel.
fruit.
Ezekiel. No,
Wise word, wise word.
Okay, I expect everybody. No, never mind. To look in their book.
I don't have a book.
Everybody turn to page
Hey, Dr. 367.
370.
Oh.
377.
I thought this was a very good example. We're gonna do it.
Tracking a move.
So I'm gonna read it because I know some of you did it first.
I got the book
I know for a fact.
right here.
So I'm going to read this. In 1985 and 1987, the Michigan Department of Natural Resources airlifted 61 moose from Algonquin Park, Ontario, to Marquette County in the Upper Peninsula. What is the Upper Peninsula? Marquette, is that Michigan? No, no! Marquette University is in Wisconsin. It was originally hoped that the population P would reach its carrying capacity in about 25 years, with the growth rate of the thing given. Now let me explain something now. How would you even attack a problem like this?
Scoot to the
Now, do you remember 2 nights ago's assignment? Okay, I'm gonna call on somebody. Kaneshiro! If the rate at which a population grows is proportional to the population, then what is the solution to this differential equation?
Oh.
P equal? P-O. I've never, you've had me for 2 years. I've never said P-O. What if it was DB? Then you go B over there.
Yeah. If it was S, you got S. So.
P naught. P naught.
P-O.
Okay, finish it off. E to the K T. But
He says Lin.
what does this graph look like? What does this graph look like if K is positive? You have exponential growth like that. I mean, realistically, what population actually grows like that infinitely large?
Bacteria.
Bedbugs.
No. Even bacteria, although it might, yeah? No, it doesn't.
Bedbugs.
No, because bacteria, there's still a carrying capacity, right? Like your
Yeah.
body, right, or whatever it is.
Well, like, what if out in the
So,
wild?
in a more realistic population growth is, the rate at which a population grows is not only proportional to the population, but the carrying capacity minus the population as well. Drosophila flies. So we have to put this in because of like predators, what would kill off, what would kill off bacteria?
Humans.
Antibiotics or
Alcohol.
Clorox kills 99.9% of
dogs?
Hand sanitizer.
Okay, so what we're gonna do today is we're gonna say, okay, what happens? For example, you guys know what the carrying capacity is? That means like the maximum number that you could have. So what would happen then is, what would happen then, I guess this is actually time versus population. Instead of the population just growing exponentially like this, it's gonna start leveling off like this.
What was that rabbit used in the tiger?
Okay, now, does anybody remember the term we used for this? We had this graph in PCH
Limit.
last time. Wait, no, I know you know.
The term.
Let's give these other people a chance. Lee, PCH. Okay, well, it looks like tan inverse, but no, it's not tan.
No.
Wait.
No. Okay, Yoshida.
Is it a sigma?
No.
No.
Who?
We call it an S curve.
It was in PCH. Okay, remember when we did exponential functions in PCH, and you had to draw those 4 graphs? Hyperbolic cosine,
Hypercosine.
hyperbolic sine,
I was
the
thinking-
bell curve, and this was the 4th one. This is called logistic growth.
Cardio.
Who takes AP biology here? What does logistic mean? Tomorrow.
Log.
I don't even know what logistic means. Anyway, logistic growth is how a population might grow according to this differential equation. So, now if you read your book, we're on page 371 now. So it says the general logistic formula. The solution of this logistic differential equation is, and they actually give it to you. And then it says, I just read it this morning. Oh, here. It says right here. I went to the bathroom, I was actually reading this. It says, in exercise 35, we'll ask you to verify the result in the box below. We're going to do it right now.
Shift to spray it.
Now, does anybody have foresight?
No.
Can you see how we're going to solve this differential equation here? That's why we studied what last night?
It's an example.
What did we know from, what do we need to know from last night's homework to do this?
Oh,
Partial fractions, that's right.
Wait,
Okay, so
it's done for you.
So, we're gonna go through how to solve this, but ultimately, you gotta memorize, just like this one, you gotta memorize. There's two you gotta memorize for the AP exam. This one, and then the logistical. So, and you're gonna find that it takes quite a bit of work to get to the solution, so that's why you wanna just memorize it. Okay, so how do we solve differential equations like this? What do we do?
Distribute, put it one side.
Segregate the variables. Remember that? So you have to put all the p's on the left with the p, dp, and all, everything else on the other side. So dp over, bring these on this side.
P.
Did you guys forget how to segregate variables? Equals k dt. Did I do that correctly?
I was told segregation is bad.
Second step, integrate both sides. Now I'll do the right side, kt plus c.
Ah.
And don't say 1/2 k squared, remember why? Because the independent variable is t here. Now how do I integrate the left side? Partial fraction. So here, we go off on the side, and 1 over p, m minus p, is equal to
1 over P.
something over p plus something over m minus p. Does it bother you that you have an m there instead of like a number like 5 or something?
No.
Yeah. Don't let it. Okay, what's the next step? Multiply
And
both sides by the
beside.
least common denominator, which is p times m minus p, and you're gonna get 1 equals a times m minus p plus b times p. Now let's use the heaviside method. What would be a good number to plug in for p?
M. M.
Yeah, either m or 0. Which one do you want to do first?
M.
No, 0.
What?
If you plug in 0 for p, 1 equal am plus 0. Hey, we just figured out a is 1 over m.
So M to the negative.
Now, what is another good number to plug in for p?
M.
M. If I plug in m for p, what do you get?
1 equals BP.
You get 1 equals 0 plus
BM.
bm. And so b equals 1 over m.
Do you know what BMing is?
bm, bowel movement, right?
Oh, never mind. That was what I was thinking.
That's how I learned it in elementary school. Why, what does BM mean now?
Yeah, like,
That's what I mean.
Bad man.
oh yeah, I
Oh,
thought it was,
yeah.
yeah, in like games, if you know
Okay,
you're
can we
gonna
just
win,
finish the start
you
problem?
intentionally start losing a little just so you can
So
crush
this
them in the
integral
end.
is the
That's
same
called
thing
BM.
as doing 1 over m over p
like if you're
plus
20,
1
22,
over
like,
m
20.
over m minus p dt
That's BM.
dp. Correct? Do you guys want to factor out the 1 over m? Or
Nah.
just leave it?
Leave
Okay, no, too late. So let's throw the 1 on the m on the outside. So we get 1 over p plus 1 over m minus p. Now you're going to get called on, whoever. So, now, if we compute this, find the antiderivative of this, what do you get, Hanuman?
P to the ln P.
My friend, my good
Natural
friend Lynn.
absolute value of p. How come you don't need the absolute value though?
Because obviously it's not going to be negative.
Why?
Because what's the problem again?
It's a population of mooses! We have a population of mooses!
I know, I just wasn't
meese.
sure.
Can you say mooses or it's just
It
moose?
is moose.
Meese. Mice. Plus Okay, wait, okay, next one, Hanuma.
M minus P. Let's see. So it's like.
The example we did yesterday of the partial fractions was just like this one.
It was just,
Natural log
it was just my good friend Lynn.
m minus p. How come I don't need absolute value for that one?
Cause the.
No, don't listen. I want the real reason. Oh, because m is the carrying capacity. You can't have anything bigger than m. So that's what remember the graph I drew? No, this is time versus population. Here's the carrying capacity m. It's not gonna get bigger than that.
Yeah.
So that's why that thing is gonna be positive. So is that the antiderivative?
No.
So what is it then?
You have to add. Or. Yeah. Don't you have to add?
You're just mumbling. Minus. There's a why is there why is that a minus?
Derivative
P.
Because the derivative of the box is negative
negative.
1. And then plus c, correct?
Yep.
Okay, so if we put that over here, you're going to get 1 over m times natural log p minus natural log m, minus p plus c, but we mush the two c's together into that constant over there. Okay, now what's the last step? So I actually did the calculus part, now it's just the algebra. What do I have to do? What are we solving for when you solve the differential equation? You're solving for p, the population, right? The equation for the population. So how do I go about solving for p here? What should I
Times
do?
by m.
Multiply both sides by m.
Combine the natural log.
Okay, shall we do that in one fell swoop?
Yeah, nah.
Combine the logarithms together then. Natural log p over m minus p, ooh, it's starting to take shape, is equal to m kt plus, well, what's a constant times another constant? It's still a constant.
E both
MC.
It's
sides.
not the same constant, but it's still a constant.
E.
And now how do I get rid of this ln here?
E.
You e both sides. So e. So you got p over m minus p. Is it the blood pressure is just going way sky high now. E m k t.
Listen parts blood pressure's in.
Okay, now here.
Stock.
We did this the last time. Okay, now.
Plus one.
Okay, isn't this the same thing as this
E,
times
C.
e to the c?
Which is constant.
Because you add the exponent. But if c is a constant, e to the c is
It's
also
also
a
a
constant.
So
Okay,
K.
now let me just see. What do we want to call this constant in this problem?
P naught.
No.
A.
Who said that? Angelo?
Yeah.
Why?
Because
You saw.
Cause that's constant.
Thank you. There you go.
Actually,
So you read the book, you learn something. We're gonna call this constant A, because that's what the book calls it.
why not like a sec?
Okay, but we're not done yet. We have to solve for P. How do you solve for P?
Segregate.
No, we did that already. Cross multiply. P equals A m e to the mkt minus A p e to the mkt.
Throw the p's on the same
Throw
side.
the p's on the same side.
Segregation.
Let's put it on the left.
Take out
P
the p.
plus A
Do
P
the one
E
swoop.
M capital capital MKT equal A M e to the MKT.
Isn't MKT a fact?
Factor out the P. 1 plus A e to the MKT. It's starting to take shape. Did you guys look at the book, the formula they had in the book? A M e to the MKT. Divide by this, so P equals A M e to the MKT all over 1 plus A e to the MKT. That's why, do you guys remember in PCH last year why we had to do all those like difficult log and exponential equations?
For this.
So that when you come to this, you know what's going on.
What?
Okay, now, is that the way it's written in the book?
No.
No, so how can we change it to make it look like the thing in the book? No, we don't do that. You just shout random things there. Use the quadratic formula. Synthetic division.
Giselle.
Kramer's rule.
Heron's formula.
Logic gates.
Heavy sign.
I'll give you a hint. In the book, the numerator is just m, all by itself. How can I get an m all by itself in the numerator?
Divide.
Divide top and bottom by a e to the mkt. So what happens if I divide that by a e to the mkt?
Oh, that's
You get
smart.
1. And what happens when I divide this by, what are we dividing by?
AE to the MKT.
Yeah.
a e to the mkt. What are you going to get?
A e to the negative.
1 over a
E
e
to
to
the
the
K.
mkt. T. K. T.
Hi, Jared.
Why?
Okay, excuse me.
Nice of you to
Okay, you're
join.
gonna just have to work outside for now.
You can work in here.
So you're just gonna make me
Nope.
too excited. I have.
And don't touch this. Okay, go.
Touch it.
Hey, you can only use calculator on the very last problem.
Jared, remember the thunder comes before the lightning.
Yeah, thank you.
Yeah, but Mr. Park, that still
I'll get the calculator right next time.
that still doesn't look like the thing in the book. M over 1 plus, now in the book, how is it written? Tran.
You said it wrong.
You know why you get picked on? Because I'm always facing there. I see you.
And one.
E to the negative.
A e to the negative nkt. Yeah, but Mr. Park, 1 over a is not a. Yeah, but if a is a constant, isn't 1 over a also a constant?
Yes.
Yeah, so it's still a constant, but it's not the same constant.
Box.
So actually, Angela, we should have called that 1 over a. But that's okay, it doesn't matter. If you have a constant, 1 over a constant is still a constant. So this is the way we remember it. So from this day forward, whenever you see this differential equation, kaboom!
Bam.
The solution is P equal M all over 1 plus A e to the negative mkt.
Alright, just reinvent the wheel.
You're gonna reinvent the wheel, really? I don't think so. Okay, so let's define all, you guys gotta understand what each of these variables are. What is P? What is P?
Population.
That's the population at any time T. What is M?
Max.
The carrying capacity, which is the maximum the population can be. What is K?
Constant.
That's this constant of proportionality here. T, of course, is time, and A
Constant.
is just a constant to be determined by the initial
Initial
conditions.
Appropriate.
Heavy side.
No, see, again, this is just random things. So
Euler's method.
let's actually do the moose problem in the book now.
Wait, we didn't do it yet.
No, we just derived the equation that we're gonna use. But now we're gonna actually do the problem, so I'm gonna erase this.
This is kind of much.
So the purpose of this was
Euler's
just to
line.
show us what formula to use.
Yeah, but don't you wanna see why?
Oh,
Yeah,
so
the derivation of it?
we never actually have to do it.
Well, sometimes we do and sometimes we don't. Okay, so this is the 0.0003 p times 1000 minus p. Like on the AP exam, they're gonna give you this differential equation and they're gonna ask you, okay, the solution of this is a logistic equation. What is the carrying capacity?
1,000.
1,000 moose in this case. Oh, and what's the initial condition? I forgot the name. P of 0 is 61. That means at time 0, you have 61 moose. Okay, so you see that, hey, this is the logistic equation. So what do you immediately write down? P equals
M.
and what is M in our problem?
1,000.
Remember, this is M and this is K. That's all you gotta know, man. So 1,000 all over 1 plus A. Now we haven't figured out what A is yet. E to the negative MK. Well, if this is M and that's K, what is MK?
3.
Point
No,
three.
come on. I can take this down to the 4th graders and they can do it.
Come on,
This is how I learned in
review.
4th grade. When you multiply a decimal by 1,000, you move the decimal 3 to the right.
That's point
1, 2, 3. It's negative 0.3
The hump.
P's.
Yeah, I make the hump.
Come on, this is review.
You're reading my mind, actually. Now, let's figure out what A is.
Like
How do I
a
figure out
blind
A?
man in the
How do I figure out A?
Initial
By
condition.
using the initial
No.
condition. If you plug in 0 for T, the population is 61. So 61 is equal to 1,000 all over 1 plus A e to the, which is 1. Hey, we can, oh, that's easy then. So A plus 1 is equal to 1,000 over 61. So A equals 1,000 over 61 plus 1.
minus 1.
minus 1.
Morning glare.
You can punch that in on your calculator and you get. Okay, those of you who don't have a book, you better be reaching for your calculator now.
0.67.
And we can mental map this.
No, because I actually did this problem in the bathroom too. I don't remember 0.6 something.
It's probably like
I
7.
remember there's like a 5 in it.
Is it 15? Is it 39?
So what?
15.39.
Gotcha. 7 times
393. Okay, there you go.
260.
Yeah, you gotta give 3 decimal place accuracy.
It's actually not.
What?
No,
So is this correct?
Yeah.
Okay, so that means this is our equation. P equals 1,000 all over 1 plus A e to the, I forgot to put the A in full, 15.393 e to the negative 0.3t. There you go. This is the solution to that differential equation. This is how the moves are going to grow over this time.
Oh, I kept it.
And for your viewing pleasure, I actually graphed it on my graphic calculator for you.
Are these
It's also graphed in the book.
stories?
It's graphed in the book?
Yeah.
Slope field.
Since when do you guys start looking at your
Since now.
Okay, see, look, right there, you see it? I punch the equation in. Hey, you're right, 15.393. And then now, with the appropriate window.
Wait, view window.
No, I already fixed the window.
0.25 by.
Wait,
Okay, you want to see the B
Personal
window?
watching this video
The
can't
B
see
window
this.
goes from negative 10 to 100. And then,
Hey, Mr.
Why
We gotta
goes
turn
from
this
next-
camera.
too bad.
Moriguchi,
Just do it yourself.
So I'm gonna I'll draw it on the board for Moriguchi.
Well, that's really nice.
Hey, that kind of looks like an integral stuff.
Oh, it does.
No, it's like a curvy.
That looks like your grade in S.
Satisfactory.
Satisfactory.
So it looks. So here, obviously, this is 1,000 over here.
Super.
Horizontal. In fact, remember in PCH?
No.
Didn't I ask you, I gave you this, no, I did. In PCH, I gave you an equation like this. It was, I don't know if it was on the final exam or on the test, additional problems, whatever. And then I asked you, what is the limit as t approaches infinity?
yeah.
I distinctly remember that. So here, let's do it for funsies right now. What is the limit as t approaches infinity? And I remember a lot of you had problems.
Fat pole.
But it's actually easy.
1,000.
No, you don't have to know
1,000.
football. Just look at that. What's the limit of this thing as
Infinitesimally small.
Zero.
That goes
Zero.
to 0, right? Because that's like 1 over e to the something, right? That goes to 0. So therefore the whole thing goes to 1,000.
I remember that.
So it makes sense that the horizontal asymptote is 1,000. Anyway, the graph looks like this. It's starting to grow. And right there is 61 moose.
Me.
Oh, mice. Dice.
So then, once you have this equation, I can ask you anything, right? Like on the AP exam. How many years, at what value of time, t is measured in years usually? How many years will it take the moose to get to 900 or something?
Or just plug in check.
Yeah, just plug in 9, so this is p equals, plug in 900 here and solve for
We'll
t,
find
right?
the
You guys
area
can do
after
that.
the
Okay, but here, I have a better question. When or where is the population increasing the fastest?
In the middle.
Take.
Now, Angelo read the book, so he knows. When is the population
When is it, Angelo?
increasing?
When is it?
the
When is it, Angelo?
Like in other words, on this graph, where do
When
you
is
have
it?
the steepest slope?
Oh, right in the middle.
Wait, we should ask Angelo. Here at the book.
Okay, Angelo.
Right there.
Yeah, you're right. Right about there.
Where it
That's the
switches
steepest
concavity.
slope. But where exactly though?
Concavity.
Yoshida, this is the kind of question you like.
Second
Yeah, you do. No, okay, it's so simple. Here, look at this equation. This represents the slope, right?
Yep.
When will this slope be as large as possible?
When p is 0. No, just kidding.
No, look at that. This is the slope. This represents the slope. What is the maximum value of this slope? I'll give you a hint, look at that. Here's another hint, it's a quadratic. Is there a way I can find the maximum value of a quadratic? Like if I were to graph this, hey, you want parabola.
Opposite.
The x-intercepts are 0 and m. Where does the maximum occur? Halfway in between it, m over 2, that's right. So, when the p coordinate is 500, that's when you have the biggest slope.
It's pretty genius.
Boy, It said it in the book. You know how I know? I read it when I was in the bathroom. Maybe you guys should keep your, take a picture of the problems, but keep the math book in the bathroom. So when you go, you can actually read, like, just one or two paragraphs, but for some of you, like 5 or 6 paragraphs, right?
Yeah.
The whole book.
I'm gonna drop the book and
I'm just gonna read
No,
these.
I'm serious, on the AP exam, on the multiple choice, they give you this and they ask you all kinds of questions, like what's the carrier's capacity? What's the value of M where the slope is the biggest and things like that. So you gotta know things about this graph. Question.
Like if that was like a square.
Wait, what do you mean square?
So imagine
What's a square?
square or imagine
I knew you were
Wait, what's a rectangle?
just the and the areas the
No, what's a rectangle?
like one of the lengths is E and one of the lengths
She
is
saw the
S.
green, it was instant.
Like that.
Yeah. And so when you change it, when
Yeah, it
you
was just instant.
in order to
Like-
the area is
Like
the
like she
maximum.
held
So the maximum area of a rectangle is when it's a square.
Yes.
oh
And so like when you change it, because that one's like this,
Okay,
there's
that
lots-
kind of makes sense too.
Yeah,
All right, we are done.
Thank you.
We are done.
we're over.
It's not, it's
Bye, Moriguchi.
Oh, again.
Bye.
Goody Gucci gang.